Today's lesson is on quadrilaterals. Because of their rigidity, triangles are structurally useful. But when it comes to building things that have to stack or fit together, like books, doors, beds, and containers, triangles often don't work very well. Many objects you use every day tend to be quadrilateral shapes, which means they have four sides. The most common quadrilaterals are the square, and the rectangle. To be a quadrilateral, a shape must have the following properties. The sides join to form a closed path. The interior angles always add up to 360, and the four corners must lie flat on the same plane. So we have different shapes. Here, this is a square. We have a rectangle, a kite, a parallelogram, a trapezoid, and a rhombus. There are several kinds of quadrilaterals, each with their own properties, and they're very unique. In this section, we will learn how to distinguish a square from a rectangle, a kite from a rhombus, and a trapezoid from a parallelogram. All right, properties of squares, rectangles, and trapezoids. Pauline is laying out the corners for a square patio next to a building in Whitehorse, Yukon. In addition to the basic properties of a quadrilateral, what must the patio have? Consider the measure of the corners. So if it's going to be square, what's the measure of the corners? The corner angles have to all be 90 degrees. Parallel lines, you have two sets of parallel lines. They're opposite each other. Okay, so this is parallel to this side, and this side is parallel to this side. Okay, those arrow marks mean parallel. The length of the diagonals, well, they will actually be equal in a square. AC will equal DB. One further thing is the side lengths must be equal if this is going to be square. Okay, well, Pauline makes a mistake in measuring the length of side CD as shown. What shape has she created? Well, we actually have this side, and this side is still parallel, but the other side is not. So she's actually created a trapezoid, which has one set of parallel lines. Which measurement will identify that she has made a mistake? Well, if you measure the diagonals, AC equals BD in a square. If AC does not equal BD, then you don't have a square. Pauline locates a new corner E, so she moves this line over to here, and she measures DE equal to AC. So DE is now equal to AC. Is this shape a square? Well, she has diagonals equal. She has corners that are 90 degrees. She has sides, two sides, sets of parallel lines. But she has one problem. All sides are not equal. And she has created a rectangle. So the difference between a square and a rectangle has similar properties in that the diagonals are equal. They both have corners that are 90 degrees. They both have two sets of parallel sides. But a square has all four sides equal. A rectangle has two sets of equal sides. So that's the difference between those two shapes. In question 2, Pauline created a right-angled trapezoid. An isosceles trapezoid is another special kind of trapezoid. Examine the following diagrams. What properties must these trapezoids have? So this one is a right trapezoid, so it must have a right angle, two right angles, angle A and angle D, and it has two parallel sides. AB is parallel to B, or DC, so these two are parallel. Okay, on a isosceles trapezoid, HG is parallel to EF, but they're not the same length. HE is equal to GF. So these two sides are the same length, and the diagonals are equal. HF equals EG, and that makes the angles equal. So I'm running out of room. Angle E will equal angle F, and angle G will equal angle H. Okay, so where are trapezoids used? Actually, there are several places that they're used. Okay, so a Howey truss bridge, modular tables that are in your classroom. You will often find tables that look like this shape. Okay, there's one in my classroom. And also, the goal creases on a hockey rink are trapezoids. Jean-Francois is building a water trough for cattle, and he is going to figure out what shape this is, and he then wants to figure out how much water this trough will hold. Well, if you use a protractor to measure the angles and a ruler to measure the diagonals, you'll find that angle A is equal to angle B, and angle C is equal to angle D, and the diagonals, AC is equal to BD, and the sides, AB, are parallel to CD. This makes this shape an isosceles trapezoid. Okay, so to figure out how many liters it will hold, we're working with volume. The volume of a trapezoid is equal to the area of the base times the height. Okay, so the area of a trapezoid formula is 1/2 A plus BH. A is here, B is here, and H is the height between those two. So let's do some calculations. So area is 1/2 0.55 plus 0.40 times 0.30. Multiply those all together, and you get the area is 0.1425 meters squared. Area is always in meters squared. Okay, so then the volume is 0.1425 times the height. Now this time the height is the height between the two trapezoids, or the height of the whole trough. 1.75. So the volume is 0.25 meters cubed. Surface area is always meters squared or squared units, and volume is always cubed units. Now, capacity, 1 meters cubed equals 1,000 liters from last year. We did capacity, and then we have 0.25 meters cubed, and we want to know how many liters that is. So when we complete the cross multiplication, you find out that X equals 250 liters of water this trough will hold. I'd like you to build your skills, page 191 to 198, questions 3, 4, and 6.